I'm Anil Kumar, and in this video I'm going to discuss a very different technique of curve sketching. The example here is to sketch graph of f of x equals to x plus 1 over x. Let us first analyze this particular function. We have f of x as x plus 1 over x. Let's find what is f of minus x. The idea is to figure out whether it is even or odd function. So when I substitute minus x, I get minus x plus 1 over minus x. That could be written as minus of x plus 1 over x, right? Which is minus f of x. So that means the given function is an odd function, right? So let me write down the first result. So we are dealing with a function which is odd. Odd means symmetric about origin, right? So it is symmetric about origin. Okay. Let's find the derivative and also a local maximum and minimum for the given function. So derivative of this function can be written as derivative of x is 1 over x is minus 1 over x squared. For this derivative to be 0 or undefined, 0 or undefined, we get critical numbers, right? So let's find what are the critical numbers. So one is, of course, x is equals to 0, right? X equals to 0 will give when it is undefined. So one is x equals to 0. That is for undefined. The denominator will be 0. However, you also note in the given function here x is not equal to 0. So we have a vertical asymptote at x equals to 0. Okay, right. Now let's see when is it 0. So if I equate 1 minus 1 over x squared equals to 0, what do we get? We get, let's write it down as x squared minus 1 over x squared equals to 0, and the numerator is 0 for x equals to plus minus 1, correct? So the other two critical numbers are x equals to plus minus 1, correct? So we have x equals to plus minus 1 as the other two critical numbers. Now let's figure out whether we have a local maxima or minima at this point, right? The easy way to do is to find the second derivative. So if I find the second derivative, first derivative is right there. What is the second derivative of the given function? First derivative is 1 minus 1 over x squared. So from here we can find the second derivative, which will be derivative of 1 is 0 and minus x squared, that is x to the power minus 2. So that gives me minus, and minus becomes positive. You'll get this as 2 over x cubed. Now that gives you the second derivative. Now at plus 1, what you find here is that, now second derivative, let me write down the analysis here. Okay, so let's do in this space. I think we have enough. Let's do it here. Okay, so if I substitute plus 1, then we get a value which is greater than 0, right? Which is positive, and greater than 0 means concave up. So this means concave up, and that means we are talking about local minimum, right? Local minimum. Now if I substitute minus 1, then the denominator is going to be negative, so we get 0, less than 0. We get a negative value. So it will be concave up, and what we get here is a local maximum, correct? So we have a local maximum. Is it okay? So what we find here is that at x equals to 1, what is the value of f of x? F of x will be equals to, if I substitute 1 here, I get 1 plus 1, which is 2. So that is the local minimum, right? And the other value at x equals to minus 1 will be f of minus 1. So if I substitute minus 1 here, so minus 1 minus 1 gives me minus 2. That is the local maximum. Is it okay? Now with that in mind, let's summarize what we have found and then we'll sketch the code. So what we have found here is one odd function, correct? Then we also found that maxima is at, so local maximum is at minus 1 and the y value is minus 2. This is the local maximum, and local minima is at 1, the value is 2, correct? And we also have a vertical asymptote at x equals to 0. That is the vertical asymptote, right? Now, what we are going to do from here onwards, we could actually, this information is good enough, or we could actually sketch the curve from here. But now here we'll learn another strategy, and that is, we are given a function which is sum of two functions, right? So basically, f of x is equals to sum of two functions, x plus 1 over x. So what you notice here is it is sum of, let me write here. So this is linear, right? Okay, so this function here is linear and this is reciprocal. What I'm trying to say here is that, let me sketch. So if I sketch the function x here, so let's take a, okay, this color will be okay. Linear function, let me straight away sketch the linear function here. It will be a diagonal line going through the coordinate. And the other function which we have here is the reciprocal function, right? So which will be kind of like this. So this is the reciprocal function which I am sketching. Correct? These points could be considered as 1 and minus 1, this point, right? Minus 1. For the reciprocal function, these are invariant points on both the functions. Okay. We are looking for combination of these two, correct? We already have a vertical asymptote right at the center. So let me sketch that because of this. Denominator as a part of reciprocal function. Okay. So this definitely is a part of our final result. When you combine these two, 1 plus 1 is 2, right? So we'll get this point shifted to here, 2. Point will be 2. Minus 1 and minus 1 will give you minus 2. So we get a point at minus 2, right? If the function is between plus and minus 1, that is within this interval, then you see reciprocal function is very large, positive, or very large, negative. So in this interval, our function, the combination of these two, will look like reciprocal function. So it is going to be more like the reciprocal function. So I could sketch this function like the reciprocal function. It will approach the reciprocal function. However, as we move away from 1, the values for the linear function are very high, so it is going to approach the linear function. Since on this side we are adding positive quantities, the function will always be on above it, so it will act as an oblique asymptote, right? An oblique asymptote. So combine this thought, and we know this is our local maximum. I can sketch as this. Do you see that? So that becomes the result, addition of these two on that side. Odd symmetry, we have all the points which confirm to odd symmetry. And the reasoning here works fairly well. Here also, in this case, we are decreasing, right? We are decreasing something. So we are approaching the oblique 1 over x, oblique function x from below. So the function will be kind of like this. So that becomes the function f of x. I should write in black, right? So this is the final result, f of x, which you get by combination of the two. So the strategy here is we did combination plus we analyze the derivatives, which is the first and the second derivative, to find the local maximums and minimums. And of course, some work on the type of function, which helps us to sketch it fairly well. I'm Anil Kumar, and I hope that helps. Feel free to post your suggestions, views, and comments. Share my videos and like if you like. Thank you, and all the best.